So again, we have this constant. We're trying to show that its interpretation is in D1. By the fourth property, and let's go up and look at what it says. The fourth property says that if you pick any n to be a length of tuples and any two indices, then the set of all tuples with those two coordinates the same is in D sub n. In particular, I want to use this where n is equal to 2 and I and j are equal to 1 and 2 respectively. And this will imply that the set x equals the set of all pairs that are really just the same coordinate in each is this is in D sub 2. And in particular, it should be clear that the interpretation of C made as a pair is in this set. Now, so we have established that this is in D sub 2. Next, we are going to use the eighth property on this thing. So now that we know that this thing exists in D2, we are going to use it to split it up, so to speak, using the eighth property. And what this tells us is that since we have a set, and I'm going to take n is equal to 1, m is equal to 1, I'm also going to take b to be the denotation of C, and this is basically the, this I'm regarding as the latter part of the tuple, right? So for this tuple, I'm taking this to be B. And what this says is that in D sub n, remember, n is 1, m is 1, so we're talking about D sub 1 now, and I am looking at the set of all prependings, so to speak, right? A is the set of all prependings of the term that I've chosen here, B. But in this set, right, if you recall, in this set just is made up of the things that have repeat coordinates. So there's precisely one prepending of Cm in X, namely Cm. There's nothing else in the set that has Cm here, because they all are repeats in both coordinates. So we have just established that the set which is equal to just Cm is in fact in D1, and that is the proof for the constant term. I'll, cut the video off here.